To get our minds around the physical world and how it behaves, humans develop models to represent the physical world. Those models are necessarily simplifications of the actual physical world, but they are useful tools for understanding it and hopefully being able to describe it and maybe make predictive statements about how it would behave. So they represent reality, but they're not reality. They have limits, and it's important to know those limits. For example, the Bohr model of a single electron atom is very useful and gives a lot of good predictions in some realms, but not in all realms. And so if you try and use that to describe physical phenomena that it's not applicable to, it doesn't work out so well. You might think about the map not being the territory. I have a map of my city, and it can help me navigate my city, but maybe a street is closed due to road work, and I get stuck, right? That model has its limits, and it's important to know those limits and to be able to develop better models if you need to describe physical phenomena that aren't captured by that, but to realize that even those better models are still just models. They're not reality. They're our best attempts at understanding reality. In doing that, we develop theories, which are testable explanations for the patterns that we observe in nature. And it's important that they're testable so that we can falsify theories if they actually don't describe things, or say, yeah, it seems that it works in these ranges of behavior. If you find phenomena that is widespread, you can have a law that describes that generalized pattern. And the important thing about laws, why we call it a law rather than a theory, is that it's just more widespread. So we'll talk about law of conservation of energy that we see in a lot of different domains. It's very widely applicable. So that's laws. So in physics, calling something a theory doesn't mean that it's not true. In common parlance, sometimes you say, well, that's just a theory. Well, yeah, it's a theory, but it's a theory that also works, right? So it's a testable explanation. If it's confirmed, it's still a theory. It's just it's a theory that works. So theory doesn't mean false or just a theory. Law doesn't mean that it's anyway. So that's that. And then you have principles as well. I'll be kind of using these interchangeably, but some people specify that principles are like laws, but sort of more narrow rather than your laws. So you talk about Bernoulli principle or something like that. So that's models. And in developing the models, we have theories that then we test, and sometimes we end up with laws or principles that we talk about as we talk about that. So models, theories, laws, and principles.